In this video, we'll talk about indefinite integrals, which are a notation that is used to talk about antiderivatives. So the notation that we use in general for talking about antiderivatives of a function is that of the indefinite integral. So it's this symbol here, the integral sign, followed by the function inside, dx, equaling this f of x plus c. This is familiar from antiderivatives. So we use this notation to refer to the set of all antiderivatives of a given function little f. This notation here means that this big F is some antiderivative for little f, or big F prime is little f, like we had before. And this is the general antiderivative, indefinite integral. All these words sort of come together to talk about this object here. So in terms of the notation that we have, so this thing here is our integral sign. It's how we notate what's going on here. The function f inside is called the integrand. This dx is a differential. Its main point is to indicate what variable we're using for this integration. And then on the right, you have your normal things. This is your antiderivative. And then this c is usually referred to as the constant of integration. It's the same plus c we had before, just now written in this context. So a comment about variables, like this dx covers here, it doesn't matter what letter you use for the variable of integration, it's all the same setup. So I could write the integral of f of x dx. This would be the same thing as writing the integral of, say, f of t dt, f of z dz. They all indicate the exact same set of antiderivatives. The differential part here just tells you what letter you're using, and so it's what letter is going to show up in your answer as well. Right? In general, you'd write this one as big F of x plus c, this one as big F of t plus c, and this one here as big F of z plus c, because you want the variables to match what you have before and after. And so since it's just a notational thing, we can already start solving problems with it. Because all of our rules are still the same as before, we didn't have a different way of writing them. So this here is asking us to find an indefinite integral. It results in finding the antiderivative of each term, adding them up and putting a plus c on the end, like we did in the last part. So what do I get here? Well, x cubed becomes x to the fourth over 4. 3 root x becomes 3 times x to the 3 halves divided by 3 halves. 4x to the minus 2 becomes 4x to the minus 1 divided by minus 1. Right, I'm adding 1 here, and I'm adding 1 to minus 2 gives me minus 1. E to the 2x, we know I think the antiderivative goes to e to the 2x over 2. And negative cosecant cotangent is a trig rule. This came from cosecant, so plus cosecant of x, and then plus c on the end because it's a general antiderivative. And now I can simplify out the expression if I want to give me an x to the fourth over 4 minus a 2x to the 3 halves minus 4x to the minus 1 minus e to the 2x over 2 plus cosecant of x plus c. And that's how you work with indefinite integrals. It's the same process as antidifferentiation, it's just a new notation for how this works. This notation comes up into play when you start dealing with other types of integration, and we'll come up how that relates later. But basically at this point, this is the idea of going backwards through differentiation, undoing the process, and getting a function whose derivative is the integrand inside your integral.